Hello, and welcome to the Open Systems Media webcast, ISO 26262 Made Simple, sponsored by TrustedSoft, featuring Isol. I am Ken Briota, Senior Technology Editor for Embedded Computing Design, and I'll be your host and moderator for today. If you're not familiar with us, please visit embeddedcomputing.com, where you'll find our coverage of everything related to the design of hardware and software for embedded systems. We're chock full of design articles, white papers, blogs, videos, podcasts, and lots more, and we're always adding new content and technology coverage. In today's we'll be looking at how you can leverage ISO 26262 to discover how to enable early and continuous verification, identify critical bugs, and streamline compliance in order to create safer and more reliable vehicles. You are about to learn how TrustedSoft Analyzer, a state-of-the-art exhaustive static code analysis tool, can simplify the process of ISO 26262 certification for automotive software, featuring a testimonial from Isol, a global leading developer of real-time embedded software solutions. Our speakers today are Olivier Courage, Senior Pre-Sales Engineer at TrustedSoft, and Roland Dudemain, VP Engineering at Isol, France. Before we get started, let me go over just a few housekeeping items. The entire presentation will likely take about 45 minutes. That'll leave us some time to answer your questions, and we will get to as many as time permits. You'll find on the right side of your console window an area where you can enter your questions in real time. As I said, we'll address as many as we can at the end of the presentation, and please feel free to submit them throughout the presentation. We'll be getting to them all at the end. If we don't get to your question before we run out of time, someone from TrustedSoft will get back to you with an answer as soon as possible. If you have a technical difficulty or a question pertaining to the webinar itself, for instance, your slides aren't advancing or there's trouble with the audio, please put those questions or concerns into the question box, and one of our technicians will respond to you as soon as they can with a fix. On the left side of your screen, you'll see the speaker's full bios. There's also a clickable tab there that says handouts. That's how you can download a copy of the slides that are being presented today and some other material. The on-demand version of this webcast will be available about 24 hours after we sign off today. So if you missed something, want to go back and review, or share this with a colleague or friend, you can find it again through the same link that you used to sign in today. A quick reminder that Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. One last plug before we get started. After this session, make sure you check out our podcast, Dev Talk with Rich and Vin, that covers lots of key issues and topics in embedded computing and is available on YouTube and all podcasting platforms. I think that's enough for me, though. You're here to hear from our speakers, so allow me to virtually hand off the microphone. The floor is yours, Olivier.
Thank you, Ken. Can you all hear? Yeah, I guess so. So let's speak about ISO 26262 and how we can make it simple or easy. I noticed that the presentation title was slightly different, but I think the idea remains the same. My name is Olivier Courage. I'm head of pre-sales at TrustedSoft. And without further ado, let's start. So today, I will start just by presenting quickly TrustedSoft, what we do, etc., and dive immediately in the details of the TrustedSoft Analyzer, kind of one-of-a-kind analyzer, not like the traditional ones. And I will then develop what we did for the ISO 26262 qualification of the tool, and how this tool can be used in ISO 26262 context in order to make the certification of whatever piece of code you want to certify faster and simpler. I will explain where you can get some savings and some benefits, and then I will hand over to my colleague Roland from Isol that is using our analyzer, and that will explain in how they used it and what are the benefits they got from it. And then finally, we will wrap up, and I will be glad to take your questions. So TrustedSoft in brief. So we are a software company, originally a spin-off from a French research agency. The founders of the company come from this agency, and they created TrustedSoft about 10 years ago because they wanted really to develop industrially the technology that was, let's say, incubated in that research agency. So now we are a well-established vendor of static code analyzer based on formal methods, and that's what makes us relatively different from the vast majority of static code analyzer on the market. Really, our business is the embedded software, so we don't particularly target regular IT software like web applications, etc. Our business and our know-how excels in the embedded market, and that's our only focus. We try to address specific verticals because every vertical has its own requirement. 3 of them: semiconductor, IoT, and telecom. It's a big part of our business. Automotive, and that's why we are here today, particularly, and probably our historical domain, which is critical aerospace defense, even though now it's I would say a smaller share of our activity. We are present worldwide, in Europe, of course, where the company was originally founded, but also we developed a lot in the US and in Asia too. So directly, let's dive immediately in the TrustInsoft Analyzer. So what is this analyzer and what makes it so special? It's difficult to classify our tool. There's no box that corresponds to what we do. So when we qualify it as a static code analyzer, that's probably slightly incorrect, but unfortunately, to be recognized on the market and to give a minimum of understanding of what we do, we have to use a name that's understood by the industry. So that's why we say a static code analyzer. We also do, to some extent, some dynamic code analysis because we do symbolic execution of the code. So we also have a connection with dynamic testing tools. So it's difficult to really define where we fit in the let's say the standard classification. That's why we call our analyzer an hybrid code analyzer, combining both advanced static and dynamic analysis with formal methods. I will explain later on what is formal method. And the key value proposition of this analyzer is the mathematical guarantee. It's not like oh, I think I lost my video. It's not like any analyzer where everything happens in best effort, I would say. Our analyzer is based on a mathematical core, and when you run an analysis, you have the guarantee that all the problems in the class of problems that we can find are found. It's a mathematical guarantee, and if the analyzer comes with a clean report, meaning no problem were found, it's not that just in best effort nothing was found. It's a mathematical proof of the absence of problems. So it's a much stronger statement than just we rerun and we have a clean sheet, but with the best effort analysis of traditional tools. What you see here, and I mention it now because you will not see it during the demo. Our analyzer is capable of finding extremely tricky problems, and the flip side of this is that sometimes to understand the root cause of a tricky problem, if you have a tool that just points at the line of code saying there's a problem here, but the root cause is in a different file after 10 different function calls, etc., tracking back to the root cause is very complicated. So not only our analyzer provides the traditional static code analyzer experience of running a command line and providing a report, but it provides also an interactive GUI for investigation of problems, which helps greatly developers when you have a particularly tricky problem, finding where the root cause is, even if it's really far from the piece of code where the problems happen. So what does our analyzer do? Unfortunately, we have a mathematical engine and we provide a mathematical guarantee, but not on everything. We are focused on one thing, something that's called undefined behavior. In the embedded market, the languages of choice are C and in a lesser extent C++. So we are focused on that. And in those two languages, there's something that has plagued the development since years. It's undefined behaviors. It's code construct that do not clearly define what will be the behavior. So this term is sometimes not very well known by developers, but things like buffer overflow, use after free, null pointer dereferencing, array index out of bounds, integer overflow, division by zero. All this speaks to the audience in general, and all this, they are all under the undefined behavior umbrella. It's a very important problem. It's not just a small fraction of problems found in C and C++ code, and especially in the domain of safety, because that's what we are talking about today. A lot of safety problems are rooted in undefined behaviors. So that's what our analyzer does. Today we are speaking of safety, but undefined behaviors are also the root cause of a lot of vulnerabilities in C, C++ code. Actually, 100% of arbitrary or security attacks resulting in arbitrary code execution are due to undefined behavior. So if you also have an interest in the security of your code, you can cover both with the analyzer, even if today we'll speak mostly about safety. So why is our analyzer one of a kind? Well, really the experience with our analyzer is quite different from traditional tools that you find on the market and that exist since a long time. We are using a very different technology. We'll start from the top right. Our analyzer is sound. What it means is that all the analysis has the precision of a mathematical core. It guarantees 0 false negatives. No bugs are ever missed, for the category of bugs that we detect, which are undefined behavior, but that's an important part of the bugs in C++ code, especially embedded. It's based on formal method and more particularly abstract interpretation, which is a particular technology, one of the few formal methods that exist on the market. Besides delivering 0 false negative, it also yields very few false positive compared to traditional static code analysis that tend to flood developer with a huge number of problems, which deter them from really using and looking at the problem raised by analyzers. There are too many, and out of those too many, a lot of things of a relatively minor importance and some false positive. And because of that, developers, they tend to get fed up with those tools. With our analyzer, the experience is typically that the number of problems that are raised is limited, and that's bugs that matter, meaning that's really a critical problem that would cause some sort of safety problem if you roll them out in production. Okay. Originally, if some of you know about formal method and abstract interpretations, technology that has been developed over at least 30 years, if even you can find traces older than that. For a long time, it was reserved to the research, let's say, domain, because you had to be a formal method and abstract interpretation knowledgeable person to use such tools. And one of the mission of TrustInsoft is really to bring this very powerful technology on the market. It now our analyzer is as easy to use as a traditional static code analyzer, with the benefit of exhaustiveness on top. Why it is exhaustive? It's because when you run the analyzer, you will verify that the behavior of your code, unlike testing where you try a certain number of input value, potentially many if you do a very exhaustive testing plan, but still limited number because you cannot test all combination. The property of the formal method-based static code analyzer is that you will be able to verify if there is any problem for any possible inputs. And that's really an astronomical combination. You have one example here. If you have a buffer of octets of 1024 octets, the number of combination that this represents is 256 to the power 1024. This is not something you can verify in brute force with traditional testing, and this is something that is very easy to do with the analyzer, because every abstract variable will not store a single value, but a range of values. So it makes life very easy. One of the advantages of this methodology is also a rapid increase of code coverage, because instead of testing one value at a time and hoping that each of the different values you try will explore different branches of code, you can feed all possible value at once into your program. And mechanically, this tends to exercise much more branches than what you can achieve easily with traditional testing. And our customers see the level of code coverage produced by the execution of our analyzer increasing very quickly, up to 100% if required. This is not necessary, but for example, reaching 80% is usually relatively simple. Root cause analysis, I explained it when I showed the picture of the GUI. It's only half of the job is done if you can find very complex problem, but you just point at where the problem is, and you don't help the developer in his undertaking of finding what is the root cause, because typically when they are complex, the root cause is very far from where the problem happens, and we have this complementary GUI that allows investigation of problems. Finally, because we are in the embedded market, we know that there is some relatively low-level code that might be dependent, or its behavior might be dependent on the target hardware on which this code will ultimately run. And of course, static analysis runs on traditional IT, let's say, x86 systems. But with our analyzer, we will take into account the target the hardware will run on, like its Indianness, the type of CPU, the size of the words, how padding works in structures, etc. And we can even do low-level memory mapping and alignments when you access register or you use things like that are located at fixed physical address. All this is taken into account in our analyzer. This is not really a feature related to formal method, but something that is very needed and very useful in embedded code analysis. All this makes our analyzer quite different from the rest. Also, we are well aware that in any industry, but in the automotive market in particular, you may have a different level of expectation and different depths of requirement depending on the level of ASIL that you are targeting for your certification. And in our analyzer, you can use it in different ways. I will not get into too many details. In different ways that you can adapt to your requirements in terms of quality and what are the proof or the evidence that you have to bring to your ISO 26262 certification. There are three different levels. Level 1 and level 2, they are both related to robustness and absence of undefined behavior in the code. They are relevant for any ASIL level, even when there are no ASIL. In other industry, there is no regulation, but our customers are using our tool anyway. And I would say level 3, which is really the golden standard, but also relatively demanding in terms of usage and human investment to use it. Very powerful, but also quite demanding in terms of resource. This is something that you may decide to use. It's not even mandatory for higher level of ASIL, ASIL C or ASIL D. Okay. Level 1 is very easy. It works like a testing tool, meaning that you would feed in the code that you are analyzing discrete values, 1, 3, a string, a buffer, a structure, a pointer, whatever, in the code, and the analyzer will execute the code step by step based on the source code, and there's no compilation required. and there's no hardware board required either. It will execute the code step by step to verify that there's no undefined behavior that can happen due to the injection of those input values in the code. You may wonder, but that's like testing. Actually, not, because, and you will see that during the demo, when you do a traditional test, you may have some undefined behavior that remain unnoticed by testing, whereas our analyzer will deterministically detect those problems. Why they are not seen by testing? Either because they happen only after some time of production execution in a particular context, or if the undefined behavior has no immediate impact on the test that you are running. The second level is really the most powerful part, and what our customers like to use in majority. It's the so-called the analyzer mode. And the general principle of this level is to generalize inputs, meaning that instead of verifying that your code is safe for a certain number of inputs defined in the test plan, you will be able to verify that your code is safe for any possible inputs, okay? Any possible input being all possible value for the data type that you are considering. For example, an integer can be 4 billion values from int min to int max if it's on 32 bits, okay? Or a smaller range if the relevant input value is less than all the possible value. It's very easy to manage with our analyzer. And when you do that, you verify the robustness of your code for a combination of inputs that is never doable with traditional testing. One value at a time. It would take years to verify that. Okay, functional proof very quickly, and that's the last time I will speak about it. It also allows to prove that the implementation of a function is functionally correct compared to its functional specification. Okay, so it's not only robustness, it's also a functional verification. So it goes beyond, but again, generally by experience, this is a capability that is used for the extremely critical code. To be honest, I've not seen any usage in the automotive industry yet. Most of our customers that are using that are using it in aerospace or energy domain, like in verifying software in nuclear plants and things like that. And back to the ISO 26262 qualification of the tool. This is something that we obtained recently in June 2023, precisely ISO 26262 2018 qualification. This qualification is valid for all ASIL level, ASIL A to ASIL D. And the qualification scope, because this is very precise, is that the Trusted Software Analyzer detects exhaustively all undefined behavior. It means it yields 0 false negative for all the code written in C90, C99, C11, and C18, both for level 1 and level 2 analysis, if you can correlate it to what I presented earlier. The tool confidence level is TCL3, and the version qualified right now is 145.2. We have just released a new version of the analyzer that provides additional improvements, and we have the intention to probably also qualify this version very soon. There's a safety manual available to our customers that define under which context the tool is qualified, and you should use it to get qualified results. Where do we contribute in the enormous ISO 26262 scope? So I think you know just as well as me these 3 intertwined V cycles. First of all, we only play at software level. So what is important to us is part 6, okay? And within part 6, it's section 8, 9, and 10 that relates to validation of the software. So if you take the global picture of ISO 26262, that's a tiny part. But if you zoom on the software development, you can see that the contribution is at several levels. So 6.8, software unit and implementation. By the way, we also provide a MISRA checker as a complement, even though sometimes you can find others on the market, and it's your choice to use both the TrustInsoft Analyzer and the TrustInsoft MISRA checker or different tools. And also from the up part of the V cycle in the software unit verification and software integration and verification, this is something that you areas where you will use the TrustInsoft Analyzer very frequently. What are the capabilities of the TrustInsoft Analyzer that map well for the ASIL requirement? So first of all, there are general requirement transversal to all ASIL levels that are covered by TrustInsoft. I will not show them all, and actually this will be confirmed by Roland when he will explain how the TrustInsoft Analyzer is used at ISOL. But you can see all the capabilities mentioned in the standards that are met by the analyzer. And now if you focus more precisely on the different ASIL level, we regroup ASIL C and ASIL D because it's a rather thin line between the requirements between C and D, so we put them all together. But as you can see, already at ASIL A, there's a certain number of capabilities of our analyzer that allow us to contribute to ASIL A certification. And then iteratively or incrementally on ASIL B, we provide, there's additional requirements in the standards that are delivered by the analyzer, like for example, for ASIL B branch coverage, and for ASIL C and ASIL D MCDC coverage. So it's higher, more and more demanding coverage requirements or capabilities. They are all covered by the analyzer. That's not only that. As you can see, there's ASIL C, ASIL D, you have requirements like data flow analysis, control flow analysis, fault injection test, formal verification, etc. All these are capabilities that are covered by our analyzer. Now, we can see that, let's say, qualitatively, the analyzer can contribute to ISO 26262 certification, but how does it also, how can we quantify the savings? We've been working with ISO 26262 auditors, which knows what it takes to certify code, and it gives us a certain number of information. And what is the typical effort, in particular, the typical effort that is spent on software unit verification and software integration verification. That's where the analyzer contributes the most in different ISO 26262 project with different level of ASIL. You have this in this table, okay? And the estimation is that on the two line items where the TrustInsoft Analyzer contributes, the analyzer provides a human saving of roughly 30%. And I will explain in further slides how this saving is let's say justified. Okay, so if you measure that on a ASIL B project, for example, of 500 days, this represents a saving of 46 days. If you consider a more complicated ASIL D project of 2,000 man days overall, that's 240 days of effort. Overall, that's 10 to 12% of saving on the overall project's effort. Okay. How those savings are justified? First of all, because remember our analyzer is target aware, meaning it will run an analysis taking into account the target on the on which the software will ultimately run. which brings a certain number of benefits. First of all, hardware boards are expensive. They are not always available. You can't have as many as you would like. Unlike a pure software solution where, like the TrustInsoft Analyzer, where, of course, as soon as you have the analyzer, you can start running analysis with the modelization of the hardware. You don't need to that hardware physically. It may even not exist yet. For example, if you have a long-standing project, the hardware shipment will happen only later on. You can already verify that your code is robust for that particular hardware very early. If you have several developers, they can all run the analyzer on their standard IT workstation or development workstation without the necessity to have attached hardware board. Okay. And finally, by cleaning up the problems early in the development cycle, this is a shift left concept, you guarantee or you increase your chances that your tests on target that are anyway very often mandatory, even if you use tool earlier in the cycle, at some point you have to do the test on target. You have more chances that they are successful on the first try or with fewer tries than if you do nothing in the early phases and then you test on target, you may find problems, and it's always very costly to go back to the development, understand what is happening on the target, fix it, and rerun an on-target testing campaign. The second one is a mathematical proof. So it's in terms of safety, it goes beyond testing, okay? Because when you run the analyzer and you establish mathematical proof of absence of undefined behavior, you have a higher safety confidence on your software than if you just do tests, which are always dependent on the quality and the exhaustivity of your test. And in general, running the analyzer with fewer efforts, you can achieve equivalent, if not better, safety confidence than with traditional testing. The third thing where you save is the less alarm to handle. When you use a traditional static code analyzer, the problem is that developers are flooded with a lot of problems or a lot of alarms, I would say. And first of all, it's a bit difficult for them to distinguish what are the important problems from the non-important ones. So they tend to walk away from the analyzer, okay? And secondly, even when you look at the details, there's a significant number of false positives. And developers, they don't like that because they look at the first alarm raised. It's a false positive after investigation. They go to the second one, same problem, third one, etc. At some point, they are fed up and they tend to not use the tool. We have seen many customers who say, okay, actually, we run a static code analyzer, but we are so flooded that it's just pure forms, but we don't look too much at what is raised by the analyzer. And finally, when you have coverage objectives with the analyzer, thanks to its generalization capability, you can quickly explore more branches than with traditional testing and reach your target coverage with less effort. Not to mention MCDC, which is one of the capability of the tool. And at this stage, I will hand over to my colleague Roland that will explain how the analyzer is used.
Thank you, Olivier. So ISOL is a Japanese company, but also based in France, and that's where I'm located. And so you may not know the company, so I'll do a short introduction. ISOL is focused on the embedded market. We provide embedded services and also embedded products. In particular, we provide a real-time operating system called MCOS, which is designed to scale down and scale up. It has a flavor to run on small cores, and it can be even configured to be in the automotive world running for AUTOSAR Classic platform. It can also scale up and be a full POSIX OS and even a hypervisor. In all these configurations, we can propose, we we can deploy it for safety applications and security critical applications. And so one of the main challenges to be able to propose a complex platform like this is that, of course, we need to prove or demonstrate that our software has a good enough quality. MCOS POSIX is the configuration of which I'm going to talk about today, and it's a multi-process real-time OS. So it's full POSIX, Linux-like, even though I don't like it because it is a microkernel design. And the intention is that you can port and reuse a lot of software, complex applications, middleware onto that platform. It has a few interesting properties. In the design is that it is a multi-kernel and also, it is a microkernel and also a multi-kernel. But the point is, again, that we need to demonstrate that it can run safety applications and at the same time as security applications, at the same time as non-safety, non-security application all together on the same platform. Going into details, and I mentioned multi-kernel and microkernel. So microkernel is about memory partitioning. So we need to be able to host multiple applications, multi-threading, and the API here, as the name MCOS POSIX was mentioned, is POSIX for the user programming API. And so we have the memory partitioning in place, and we need to show that it works well. Another aspect is the multi-kernel. So in a traditional real-time OS, even if it is a microkernel where you have a good partitioning of the memory, the problem is at the core, inside the kernel, there is a gigantic lock, so that when the table of threads and the synchronization of messages and internal data in the kernel goes, there is always a single table of all the threads in the platform, and that requires a lock. With MCOS, we follow the latest research in university, and it is also a microkernel for the memory partitioning, but also a multi-kernel to allow core-based separation of the execution flow. What's interesting is that in the end, when you consider the design, it's in a way like a single core scheduler with message passing. And that is the core design internally. From the user perspective, what you see is the POSIX API, more parallelism because each scheduler really acts independently, better freedom from interference, which is a good property for safety, and better, and really that multiple communications can truly go in parallel here. But coming as a new real-time OS provider, we need to demonstrate quickly that we have a good product. So to do that, of course, we need to reach the safety certification. And in the automotive world, it's 26262. So what we have to certify is all those red components here, which is the C library, so that the applications can be safe applications can be developed. Of course, we don't certify the entire footprint here. Some of the additional C library are more dynamic behaviors that are not suitable for safe application, and we also include support for that. But in the kernel, we need to have the core functionality of the microkernel and multi-kernel design here already proven to be robust. We could go with traditional development flow, and for some part of it, we do. However, we need to go faster. That means we need to provide all the evidence that 26262 requires. We need to reach ASIL-D, and we need to certify a visible amount of code on a number of platforms efficiently on a complex API, because POSIX is gigantic. So if you look from a process perspective, what happens is to be able to certify against 26262, there are a number of things you need to define. You need to define your process, your development process, and how you manage the V cycle that Olivier was mentioning before. you need to define your requirement. What does the product do? And at a high level, and then at a more detailed level. And then you need to verify that through a number of methods, a number of aspects of the verification. And so when we started to look for solutions, we found TrustInSoft, and we realized that the tool itself allows us to do not just one aspect like code coverage, but also many aspects at the same time. And so we considered whether TrustInSoft could be a possible solution. So when we looked at that, what we realized is that we already have a number of unit tests, we already have a number of integration tests, and for the vast majority of them, they are not target specific. So we can reuse many of them, and we can give it to the analyzer, and it will produce, it will basically act as a data flow analysis tool in a platform independent way. Like Olivier was mentioning it, we can run it in the cloud or on our servers. And even though it will consider the specifics of the ARM platform, for example, ARM v8a, it will not be running specifically on the board. So whatever the tool provides as a proof, we can reuse the proof on any ARM v8a. And that's powerful. It's designed to run in CI because there's no hardware. And it's actually interesting because even things that can only be produced in theoretical cases can be simulated. There are some corner cases, especially in an operating system, which are very difficult to produce. For example, hardware failures or like shared memory attacks from the application. And actually, because it's all modeling based on code, this is actually capable of, the tool is capable of simulating all this. What you can't do is, of course, simulate hardware. So if you want to verify an Ethernet driver, this is not the right tool. If you want to do a system testing, that's also not the right tool. It's meant for unit testing. It's meant for the low part of the V cycle, like Olivier was showing. But that's already a big amount of the development there. And because you can describe a lot of the behavior of your APIs and then low-level requirements and even sometimes middle-level requirements, you can verify properties and behavior of your code and modules. So that's quite good. So analyzing further, we worked with TrustInSoft, and we realized that, okay, well, even though the code, the tool is designed to be able to analyze the flow of execution, so it's a data flow tool, we can also produce at the same time as the data flow analysis tool that it also covers the control flow. It also covers the code coverage aspect of it. We cover fault injection. We cover interface testing. This is, well, you have a module and you can exercise the module in all the ways that you want. Because of the data flow aspect, it will verify that all variables are accessed with initialization. So even what we found is that even when you have a static analysis tool that will check uninitialized variables, that kind of other tool will find it on only locally in the code. But if you pass it to another function, another module, another something, and it's actually used uninitialized far, far away, this analyzer, TrustInSoft analyzer, will find it. And so there are a number of activities which are covered by 26262, required by 26262, which are covered all in one go by the analyzer. Again, it's not useful if you want to do hardware in the loop testing because it doesn't simulate hardware, or you have to create a model of the hardware by yourself, and then it will fit in. There are other things in 26262, like verifying that there is only one entry and one exit. The analyzer itself will not do it. TIS-MISRA may be able to verify some part of it. But from a large perspective, it's another tool that can fulfill this. Similarly, verifying that your requirements are correctly implemented, it's your test code that verifies it, not the analyzer. So, okay, we considered that the analyzer was suitable for a large part of the activities where if we don't use it, we need to use more tools, we need to do more independent activities to show that the software is working fine. But with this analyzer, maybe we have an opportunity to group all of these pieces of work together and have the combined benefit of doing one analysis and have all these activities covered. But is it real? And of course, we didn't believe in it. So what we did is we initially did some benchmarking with them, and we tried some 3 types of applications. Initially, we tried some very isolated piece of code, which is a memory allocator. We have as I mentioned, ESOL is actually very good at performance improvements. So we have a memory allocator that is working also in parallel, multi-core, multi-thread, without any lock. This is uncommon for memory allocators. And so we were wondering if the tool, the TIS analyzer, could actually manage this. And it was interesting because that was actually a very simple case. Because TIS analyzer can take a piece of code and model it around using the real code, and consider all the inputs and outputs, including when you tell it there are third-party changes at the same time in the modeling, then we could actually reproduce and find some bugs in the memory allocator that we already resolved. But instead of taking 3 months to resolve them, it took 3 days. The application code was the next stage where we found, okay, so memory allocator is a very specific piece of code which has very specific coding constructs. But how about, okay, we want to use it not just on the allocator, but on our complete C library, on the kernel, on even some applications. So we took one application code, and that is part of our MCOS hypervisor, which is the console bridge, multiplexing the consoles of multiple guests. And actually that came easy because the typical entry point for a test is main, and so we just used main from the console bridge, and it worked. We could reach a reasonable coverage from one bug, and that was good. Then we tried on the other one, which is the core of the scheduler in the multi-kernel design, which is very unique with that message passing single scheduler communication. So that was actually a challenge. We figured that some of our code was needed some rework at some point. That allowed us to to understand much better how the analyzer is working, and that helped us for the phase 2. So after testing that and figuring out that okay, the tool is real, we started to evaluate what is the risk to adopt the tool. If we don't use the tool, actually we're fine. We can still use the traditional way. We can still use the code coverage tool. We can still do other methods which are more traditional, but we don't reach the same result, and we don't reach it in the same amount of time. We can go faster there. So instead of just going head up, we actually used some engineering services from TrustedSoft. They helped us put in place the first version of our CI and test suite to de-risk the adoption, and that helped. And we could actually then understand how that was going to be applicable. And then the third phase is the adoption, because once you have understood, usually you have one or a couple of engineers who discover a new tool, but once you deploy it to your internal team with more engineers who are not maybe thinking in the way that the TrustedSoft analyzer requires it, there's an additional effort. And what we realize is that actually some of our integration tests were actually unit tests. We could move them, reorganize our test suite, and that improved the quality of our tests and also the traceability to our requirements. And this phase 3 has helped us to improve, and it's still going on. Actually, it's we're still considering and adopting and adopting and adapting how to use the tool in our general tool chain. So this is our vCycle, and so still there are some lessons learned that I want to share. One of the challenges that we had, when we started to use Thisanalyzer is that we already had code. It was not start from zero. So the difficulty there is that some of our abstractions layer and interfaces of our modules were actually not so clean. But now the tool was able to point out, okay, that doesn't make sense, or you're now using incorrectly your interfaces because it was using uninitialized variables or things like that. I'm not saying that we were doing a bad job, but there are aspects where you don't focus and the tool will find them, which is good because you want to find bugs early. Again, shift left. But we don't just trust the tool. Because we provide an operating system, we run on the base of the software platform. We actually run on physical hardware. So this is only helping for the low level to verify the unit test and the basic behavior of the APIs. But our CI also runs on physical hardware. We still verify on the physical hardware. And for some part of it, we reuse the same integration test on the hardware and in the simulator. What we found is that the level 2 is the most useful for us, the analyzer mode. It requires to understand how the tool works, but also it's giving you the range testing, which is very useful because instead of giving one input and giving just a minimum, maximum, median, +1 approach for testing, you can just give it the whole range or give it the error case and the success case and verify that, yes, the success case actually produces only success, and the error case produces only that kind of error for that kind of input. And so you can truly verify for every value the real errors that you're supposed to get, which is very powerful because the tool can help you to do exhaustive testing. And so ACSL, the level 3, which is the formal annotations of the code to formally describe the interfaces, we don't use it so much. We use it piecewise here and there in places where it actually makes a lot of sense to verify specific properties. And I think we will use it more and more in the future, but it doesn't help for on-target verification. So we still use it in a limited way. So all in all, now we use the tool daily. We use it. We do almost all of our unit tests using level 2, and we've actually almost stopped doing unit testing on hardware. However, we do extensive integration tests and extensive system tests on hardware. But that means that the daily development is also affected. Code coverage is done by using the unit test. So although we also have another tool for doing code coverage on target, we can do code coverage. It's really just to verify at the same time that the theoretical code coverage is also very good. And this is helping because in our context, again, real-time OS needs to be robust. It needs to be safe from the perspective of the safety certification. And it also needs to be secure. And the security aspect is where exhaustive testing is very important. And this is where Thisanalyzer helps. Well, yeah. We strictly follow the safety manual that they give. It's interesting because this was very important to understand how to deploy it correctly in our CI. And we're in the final stages of doing our ACLD certification. We hope to have it very soon now. So all in all, it was an interesting discovery. We still use the Thisanalyzer, the TrustInSoft support regularly, and they have good feedback. But the tool is bringing value for us right now. So back to Olivier. muted. Now you're back.
Thank you. I will wrap up very quickly because I would like to allow for a few questions if there is any. So first of all, remember, so the tool is ISO 26262 qualified, meaning that all the artifacts produced by the tool can be used for ISO 26262 certification. It also covers MISRA and CERT if you need. It provides a really advanced safety and security. And depending the way you use it, either level 1, level 2, or even level 3. And for each of the level at different depths, I would say, you can adapt your needs to the level of certification that you target. In all case, it provides mathematical guarantee of exhaustive analysis, zero false negative. And the other advantage is that in the context of certification, but more generally in the context of software development for embedded software, it provides in many ways really a cost-effective validation of your software because thanks to really achieving quickly high level of coverage with fewer tests, validation on regular host without necessity for hardware, ability to integrate in CI, etc. And I think that's the most important part. And now, if we have time, I would open the floor for question. Off to you, Ken.
Hi there. Hi, folks. Unfortunately, we are at the end of our time, so we don't have any time for questions here, but I do want to remind everybody that although we didn't get to your question, one of the folks from TrustedSoft will be in touch with you as soon as they can. We had some great questions come in, so Olivier is going to be busy so moving through those and answering them all. Remember also, folks out there, you will receive a link to the archive of this presentation after the fact, probably around 24 hours. You'll have a chance to view it again later and share it with colleagues if you'd like to. I'd like to thank Olivier Courage of TrustedSoft and Roland Dudevant of ISOL for the wonderful presentation. There was so much information in there. I know I'm going to go back and rewatch just to make sure I didn't miss anything. And of course, TrustedSoft, thank you for sponsoring this event. And everyone out there, just remember, none of these things would be possible without you, the engineers. Thank you all for attending and have a wonderful day.
Thank you. Bye-bye, everyone.